Wanamaker. I really appreciate University of California Riverside Extension Program for providing me with the opportunity to learn to use Moodle while sharing a topic of my interest with you. This is an exciting time to be alive. We Earthlings may have many problems to deal with, such as the need of our planet Earth to convert to renewable energy. But we're also equipped with many tools, terrific minds, and fantastic ways of communications. My thirst for solution for Earth's energy problem, combined with my online teaching, allowed me to travel to various places from time to time to search for an answer, to seek lessons learned and wisdom gathered. Yes, I've attended many lectures by many scholars who have studied the energy issue. So in the following sessions, I would like to share with you the topic of why and how we should power our planet Earth with sun, water, wind quickly, by presenting some of the discussions and conclusions of various experts in the field. So let's start by asking the question, why? Why should we power our planet Earth with sun, water, wind quickly? So let's move on to the next slide. That's slide number 2. As you can see, there are 4 important factors why we should power our planet Earth with sun, water, wind quickly. Among many of the experts, one of which is the Stanford professor by the name of Mark Z. Jacobson, and based on much of his studies and experiments and conclusion that the data we have seen is that temperatures are rising quickly, Arctic sea ice area is decreasing rapidly, air pollution mortality is one of the leading causes of death worldwide, and higher population and growing energy demand will lead to worsening air pollution and climate problems over time. So let's embellish upon this in the next few slides. So let's go on to slide number 3. Here in slide number 3, you can see the global temperature trend, and it's definitely rising quickly. Between the years of 1860 to year 2000, we're showing you data in terms of both annual average and 5-year average. The annual average will be in blue dots, and the 5-year average will be presented in the red line. And you can see the consistent patterns upward, especially in the recent years as it gets toward year 2000. Even the rate of increase has dramatically increased. So let's go on to slide number 4. Here in slide number 4, you can see the Arctic sea ice area is decreasing rapidly. And the Arctic sea ice is, between 1979 to 2000, the mean was about 15.6 million square kilometers of steady decline. This is one of the reasons why we need to act quickly, because declining sea ice results in uncovering low albedo. Albedo means how reflective something is. This uncovering of low albedo ocean below results in a positive feedback of warming and accelerate the warming as it is occurring, because you no longer have a highly reflective sea ice snow surface. You have a low albedo, non-reflective ocean surface, and this triggers warming of the ocean and faster warming circulation of the ocean in the planet. So let's continue on to slide number 5. Here in slide number 5, we'd like to show you the effect of air pollution, because air pollution mortality is one of the leading causes of death worldwide. And here, very close to home, it's a photograph of Los Angeles air pollution and what that is like. And let's continue on to the other side of the planet, and let's move on to slide number 6 and see what it's like on in other parts of the world. As we travel to other parts of the world, here are photographs of Beijing, and you can see that on the left-hand side of the photograph, the Beijing air on a day after rain, and on the right-hand side is a photograph of a sunny but smoggy day at the same location in Beijing, China. China has 16 out of the 20 worst pollution cities in the world. For example, there's a city by the name of Linfen, China. Someone who lives in that city is like smoking 3 packs of cigarettes per day. And And that city is the highest child mortality in the world. Okay, let's continue on to slide number 7. Now in slide number 7, we have an image of satellite image over Asia. And we know the full fact that higher population and growing energy demand will lead to worsening air pollution and climate problems. And the darkness, this is what's called Asian brown cloud over Asia. And the black and brown carbon, in addition to CO2 or carbon dioxide, would also cause global warming. The darkness of this pollution is also contributing to warming, not just the CO2 causing the global warming, but also the black carbon and brown carbon, which are aerosol particle components that absorb sunlight. The black carbon absorbs all wavelengths of light, whereas the brown carbon absorbs preferentially the blue and green wavelengths. That enhances warming per unit mass 1 million times more warming than the CO2. And there's more CO2 in the air than black carbon. And the lifetime of the particle is really short. It's about a week or 3 weeks. The only way to slow down the sea ice loss is by reducing the soot emission that results in black carbon and organic carbon. Because even if you eliminate all of the CO2 today, it'll take 30 to 50 years to reduce the atmospheric concentration by down to 37%, or 1 lifetime of CO2. Whereas if you eliminate all the soots today, you can eliminate the atmospheric burden within a few months to a year. As a result, you can have a rapid cooling. The total cooling due to all the soots in the world, which means due to the black and organic carbon, contribute to 16% of the global warming. CO2 is about 45%. So if you can eliminate all the global warming contributed by the soot particle in the world, you can save 16% of the mortality due to air pollution. That is 16% of 2.5 to 3 million premature deaths per year due to air pollution or global warming. Okay, let's move on to slide number 8. Now, in slide number 8, I want to demonstrate the fact that I understand some of you may wonder or think that, well, the Asian brown clouds is, what does that have to do with me? It's on the other side of the planet Earth. So I would like to demonstrate for you that we're all connected. We're all in this together. Because particulates from anywhere on planet Earth will eventually affect all parts of the planet Earth. And at this particular video you see, at this particular site, that actually demonstrates how this dark brown clouds is going to be circulating over all parts of the planet Earth. So we will feel free to take a look. We are all in this together. And after you finish the video, you can go on to slide number 9. As we've come to our last slide number 9, I hope you remember that what we have discussed today in terms of why we should power our planet Earth with sun, water, wind quickly. And some of those motivating factors are temperatures are rising quickly, Arctic sea ice area is decreasing quickly, air pollution mortality is one of the leading causes of death worldwide, and the higher population and growing energy demand will lead to worsening air pollution and climate problems over time. And due to our time constraint, we will reserve discussion on how we should power our planet Earth with sun, water, wind quickly in the next session. So please stay tuned until we meet again in the next session, and hope you have a good day. Signing off, Susan Sun, Nana Maker. And be sure to check your video that I've been talking about after this. Thank you.